Hi ladies, this is Mrs. Blaufuss, and this is the last lesson in chapter 4, and it's about quadratic functions and models. So I want you to think about our chapter 2, and we did linear regression. So that was where we made a scatter plot of some data and then found the best fitting line. Well, we're going to do a similar thing in this chapter, but this is quadratic regression. And so in chapter 2, we did linear regression, linear meaning a line, and now we're going to do some examples with quadratic regression, meaning a parabola. So instead of your graph of scatter points looking like a line, it's going to look more like a parabola. So we've got a key vocab term, and it's best fitting quadratic model. And this model is the model that's given by quadratic regression. So again, from chapter 2, we did linear regression. In chapter 4, we're going to do quadratic regression. In chapter 4, specifically this lesson, 4.10. So looking at this graph, the question is to write a quadratic equation for the parabola that's shown. Well, if you look at the graph, you can see that you have 2 points. You have the vertex, and then you have another point. So you're going to start, you have a few different forms, and the quadratic form that you're going to use for this model is vertex form. So let's just think about what vertex form is again. So I'm going to write this out. So vertex form for our quadratic function is y equals a times x minus h squared plus k, where your vertex is hk. So we can get the vertex just from what's given, but we still need this piece. We still need that constant a. So we can write the vertex, and let's go ahead and put it in vertex form, and we'll leave a into the equation. So we know that y equals a times x minus h. So in this case, it's x plus 2 squared minus 3. So our h is -2, so minus -2, and our k is -3, so plus -3. But we still need, again, we need to solve for this a, and so we're just going to take another point and put that into the equation and solve for a. So we have this other point that lies on our parabola, 0, 5. So let's go ahead and plug that in for x and y. X is 0. When x is 0, y is 5. So 5 equals, we still don't know our a, but it's 0 plus 2 squared minus 3. And now we can simply just solve for a. So we'll simplify. 5 equals a times 2 squared minus 3. 5 equals 4a minus 3. And we need to add 3 to both sides. So 8 equals 4a. And then divide each side by 4. So 2 equals a, but that's not the question. The question is to write a quadratic equation. So now we know our h, we know our k, and we know our a. So our quadratic equation is y equals 2 times x plus 2 squared minus 3. This is our quadratic equation for this graph. All right, so the next one, write a quadratic equation for the parabola shown. This time we have 3 points. But notice we do not have a vertex. We don't know what the vertex is, we don't have it. There's not a super easy way to find it until we write the whole function out. But what we do have is our zeros. So we have the two spots where the parabola intersects with the x-axis. So let's use intercept form for this. We have the intercepts, so use intercept form. So intercept form is y equals a times x minus b times x minus q. So let's look here. P is -3, Q is 2. So y equals a times x plus 3 is minus a -3 times x minus 2. Now again, we still don't know what our a is, but we have another point. So we have this other point, so let's plug that in for our x value and a y value. So now we know that -4 equals a times -2 plus 3 times -2 minus 2. So we're plugging in -4 for our y value and -2 for our x values. So we can simplify. -4 equals -2 plus 3, which is 1, and -2 minus 2, which is -4. So -4 equals a times -4. To solve for a, let's divide both sides by -4. We get -4 over -4 is a. -4 over -4 is 1. So our a is 1. But again, that's not a question. It did not ask us just to solve for a. It asks us to write a quadratic equation for this parabola. So y equals a, which is 1. We don't need to write out our 1. So y equals x plus 3 times x minus 2. Now, if it asked you to write it in standard form, you would have to actually factor that out. So if it just asks you to write a quadratic equation, this satisfies this quadratic equation. But if it asks you to write it in standard form, then you would have to actually factor this out. So in this case, it would y equals x squared minus 2x plus 3x minus 6. All right, so example number 3, it says write a quadratic function in standard form. So again, it asks for standard form. That's y equals ax squared plus bx plus c. For the parabola that passes through the points -2, -6, 0, 6, and 2, 2. So this problem is a little bit different because it does not tell us what the vertex is, and it does not give us 2 zeros, it only gives us 1 0. But then it gives us 2 other points. So we're going to use standard form for this type of problem. And so the first thing we're going to do is substitute coordinates in for each point into our standard form equation, y equals ax squared plus bx plus c. And we're going to do this in order to get a system of linear equations. So let's start with the first point, where y is -6 and x is -2. So we have -6, that's our y, equals a, x squared plus b, x plus c. And then I'm just going to simplify this. Negative 6 equals 4a minus 2b plus c. So that's our first equation. And then we're going to do the same thing with the second equation, with the second point. So the second point is 0, 6. So 6 equals a times 0 squared plus b times 0 plus c. And then to simplify that, 6 equals 0 plus 0, 6 equals c. And then the third set is 2 and 2. So y equals a times 2 squared plus b times 2 plus c. And then again to simplify, we have 2 equals 4a plus 2b plus c. All right, now I have a system of equations. I have 3 equations and I have 3 variables. So now I can solve for each of those variables. So C, I've already solved for C. So I'm going to start by substituting C into both of these equations, and now I will have 2 equations with 2 variables. So the first one, negative 6 equals 4a minus 2b plus 6. And I'm going to simplify this. I'm going to subtract 6 from both sides. So I get negative 12 equals 4a minus 2b. And then over here, I'm going to do the same thing. I'm going to substitute in C, 6 for C. So 2 equals 4a plus 2b plus 6. And then I'm going to subtract 6 from both sides. So negative 4 equals 4a plus 2b. And then with these 2 equations that I have, I'm going to write them side by side just because I think it's a little bit easier to solve. So negative 12 equals 4 minus 2b. And negative 4 equals 4a plus 2b. So I'm going to use elimination here since I have a negative 2b and a positive 2b. So I get negative 16 equals 8a. So I can solve for a at this point. So divide both sides by 8, and I get negative 2 equals a. And then I'm going to go back to one of these equations. Let's say the first one. Doesn't matter which one you use, but. And I'm going to substitute in negative 2 for a. So negative 12 equals 4 times negative 2 minus 2b. Negative 12 equals negative 8 minus 2b. So I'm going to add 8 to both sides. Negative 4 equals negative 2b. I'm going to divide both sides by negative 2. Negative 4 divided by negative 2 is 2. So now just to write it all out, my a equals negative 2, my b equals 2, and my c equals 6. That's not the question though. The question is to write this in standard form. So in standard form, I have y equals a negative 2 x squared plus b x plus c. So this is my equation in standard form. So these types of things you already know how to do. You've done this before. You could even have used a once you had all three of these, you could have used a matrix to solve. The reason I did not use a matrix is because I already solved for C. So since C was already given, since one of the zeros is already given, that's why I didn't use a matrix. But had it been a little more complicated, you could very easily plug this into a matrix into your calculator. All right, so let's look at the next one. This next one is very similar, and the process is the same. The only difference is now that you don't have a zero, so you don't have any zeros. Again, you don't know what the vertex is, so you have to use system of equations in order to solve this. So I'm going to write out my three systems of equations, and actually I would encourage you to do this on your phone. So why don't you pause the video to get some practice with this. You can use a matrix if you'd like, or you can solve using elimination and substitution like we did in the previous example. But try this on your own, pause the video while you work, and then you can unpause for the solution. So my first step is to write out all three of the equations in my system. So you can see for each point from left to right, I have three equations and I have three variables. So I can solve using elimination, substitution, or I can use matrices for this. I'm going to walk through solving the system, and I'm going to use elimination. But again, if you want to use matrices, you can also use that method. And I'm going to start by eliminating C. Okay, so as you can see, I multiplied the very first equation by -1 so that I ended up with a negative C, and then I used that revised first equation for both the second and the third equation in order to eliminate C in both of those, and I got two new equations. And within these two new equations, I'm going to choose to also use elimination, and I'm going to eliminate B so that I can solve for A. And when I did this, I got A equals -1. So whatever equations you use or whatever method you use, you should get a solution for A as -1. And then I'm going to use that to go back and solve for B. And then once I have A and B, I can go back and solve for C. Solving for B, I got 3. So I plugged in -1 to this equation here, and I got B as 3. And so now I'm going to go back and I'm going to use one of the original equations that has C. So I'm just going to use this one right here. And it doesn't matter which one you can use any. But now I have an A and a B, and so I'm going to solve for C. And when I did that, I got a C value of -1. So that's not the question. It's not to solve for A, B, and C. It's to write a quadratic function in standard form. So now that I have all my A, my B, and my C, I can write it in quadratic, in standard form. So y equals A x squared plus B x plus C. And make sure you simplify this. You do not need to write -1 if you're multiplying because it's the identity. So y equals -x squared plus 3x minus 1. That is my quadratic function in standard form. All right, this next example is to use your graphing calculator. So please take out your graphing calculator. And there's a few steps that you have to follow. So I'm just going to jot these down here. You want to clear anything you have in your y equals. So go to y equals, make sure that's completely cleared out. Then the next step that you want to do is to make sure the plot is on. So you have to scroll up on your calculator and turn that plot on. So it should be highlighted when it's on. And then set your window. If you look at the data, the x goes from 0 to 8, and the y goes from 3, the highest looks like it's about 40. So I want my windows to include all of that. So my x minimum, I usually like to see a little bit beyond my graph, so maybe I'll just set that at -2 since the lowest is 0. And then my max is 10, but I'll just make it a little bit bigger, 15. And then my scale is fine at 1. And then my y minimum doesn't go even to 0. So my y minimum I can set at 0. That will for sure cover the lowest point, which is 3. And then my y maximum, it goes up to 40. I usually like to see a little bit past that, so I'll go to 50. In my scale, that's how many units each tick mark represents. I don't want 50 tick marks on here, so I'll just set it to 10. And you can set it to whatever you want. It doesn't really matter, but just make sure that you pay attention to your scale when you're actually looking at the graph, so I don't think it's 1 or 2 when it's really 10 or 20. All right, and then we're going to enter our data into lists. Enter data into our lists, which we find in the stat section. All right, so let's go to our calculator. Let's go to stat. Right now, I think I have stuff in my list, so I'm going to clear list 1. Here on your calculator, you can see that L1. Just enter, and I also want to clear my second list because that's where I'm going to enter my data. So stat, clear list, and clear list 2. All right, so now when I go into stat, I can edit, and my list 1 and 2 are cleared out. So I'm going to go over and I'm going to enter all of my x values in list 1 and all my y values in list 2. Make sure that your x and y values correlate. So when my x is 0, my y is 3. So it's especially important when you have a long list of things. Here we only have 5 points, so it should be pretty simple to keep those straight. Okay, and then we're going to graph those. So if you notice the trend, it looks like a parabola. So notice the trend. And now if I want to do a best fitting graph or a best fitting model, I'm going to expect to see a quadratic function because I know that a quadratic function outputs a parabola. So in order to do that, we're going to use linear regression. So you go to stat and then scroll over to calc. And before we did linear regression, but this time we're doing quadratic regression. And quadratic regression, let's see, where is it on here? It's number 5. Quadratic regression. So I'm going to look at list 1, that's my x values. Y is my list 2. And then I'm going to store my equation so that I can graph the line. So to do that, you go to that vars then, the variables, and I'm going to scroll over to my y variables function, and I'm going to store it in y1. Then I'm going to calculate. So when I calculate it, it gives me this big long thing, which I'm just going to pull over here. But it also gives me the generic formula, y equals ax squared plus bx plus c. So it gives me my a, my b, and my c. So now to write a function for that, I'm just going to substitute those values into my quadratic equation. So now if I go back to my calculator and I actually graph that, it goes pretty closely through all those points. Not perfectly through all of them, but pretty closely through all of those points. So that's my best fit model. So the second one, try on your own. Use a graphing calculator to find the best fitting model for the data in the table. If you need help going through each of these, then please refer back to the previous example. But I'll just kind of show what the final graph looks like and what your equation is. One reminder is do not forget to clear out your lists and don't forget to clear out your y equals. If you just type over your list, that'll work fine too. I have to correct myself and go back to that last slide before you get the solution for this next one because I wrote down the wrong equation. So this was the baseball model, the first example, example A, that I just showed on my calculator. And so this is the quadratic regression information that we got. And when I wrote it, I just wrote the wrong equation. So this one should be y equals A, which is negative 1.55 x squared plus 15.18x plus 3.37. So I had written on here actually the solution for part B. So part B looks pretty similar. So here's what you should have gotten on your calculator. A parabola that looks, or a scatter plot that is in the shape of what you would expect to be a parabola. So you expect a quadratic function for this. Here's your quadratic regression information here. And then if you actually graph the best fitting line, you got this parabola. And your solution here is y equals negative 1.54x squared plus 12.69x plus 3.91. And I had written this on the previous example, but this actually is for example B. So please jot down any questions you have, and I will go over them with you one-on-one, or if we have time to do so, answer questions in class. Thank you.